Myself Meghamala from Electronics and Communication Department, Institute of Aeronautical Engineering. And coming to today's topic is about the strength contention with Trireg nets. So today we'll be discussing something about the strength of a particular signal that we have passed. Okay, the strength and the contention of the strength based on the signal and the Trireg nets. So here coming to the strength. So what is the strength here? So the strength is nothing but the nets have strength values to allow more accurate modeling. So already we have discussed regarding the nets. Nets are nothing but the variables in the Verilog primitives. Usually we will represent the variables in terms of nets, right? So while representing the nets, we'll represent the nets in terms of wire or out. So these are the representations of variables in terms of net with respect to the wires and the out. In the program, we represent the wire and the out. So these are nothing but the variables, nets. So the strength nets have strength values to allow what? To allow more accurate modeling. So in order to achieve the particular strong modeling, in order to achieve a great modeling, we use the nets, whatever the nets have. The nets have some strengths. So the strength is based on the delays as well. So some strengths, the strengths of that particular nets, they may have 0 strengths. Sometimes they may have the strength 1. Okay. So based on the values or the variables that it is having, the variable consisting of some values, it tells us the strength of that particular variable. So here the syntax goes like this: strength 0. Okay. Strength 0, and we have strength of that particular module, and strength 1 with respect to the strength of that particular module and the cap strength. So here we are seeing 3 types of strengths based on strength 0, strength 1 and the cap strength. So these are the 3 terms, three terms we'll come across when you wanted to decide the strength of a particular signal. So here for strength 0, we will represent equals to strength 0 is nothing but high Z0 and pull 0, strong 0, supply 0 and weak 0. So here as the strength is 0, when the strength is 0 is nothing but what? In all the aspects, the strength or else the delay or else the signal strength would be 0 in all the aspects. So when the strength is 0, we have the high impedance input will be 0, and the resistance will be 0, strong resistance, and the pull-up will be 0, okay, and the supply will be 0, and the weak of a particular strength will be 0. And when it comes to the strength 1, so strength 1 says that it is a high strength, high variable, high net. So for the strength 1, we see the strength 1 represent that in all the aspects, the degree of that particular strength, the signal, the degree of that particular signal would be high in all the aspects. That is high Z1, that is pull would be 1, weak would be 1 and supply would be 1. So this is a small difference between strength 0. Okay. There is a small difference between strength 0 and strength 1. So this is a small difference between strength 0 and strength 1. So the only difference that we can make out between the strength 0 and strength 1 is the strength 0 in all the aspects the value goes to low, that is 0, and in strength 1 in all the aspects the value goes with the high value, that is 1. And coming to the cap strength is nothing but it just gives a degree, the value of that particular strength based on large, medium and as well as small. Okay, so this is nothing but the syntax how we follow is strength 0, strength 1 and the cap strength. So each and every strength we can write in terms of closed bracket and in terms of the square brackets. And then coming to the description. So the description talks about the Verilog has the driven strength. So regarding the strengths in the previous classes, we have discussed about the strength based on the variables, based on the values the variable is holding, and the strength would be decided, right? So the Verilog has driven strength, 3 capacitive strengths and high impedance. This is not a strength. So here the Verilog has the 3 terms, that is driven strength and capacitive strength and as well as the high impedance strength. So when it comes to the signals, if you want to decide what sort of strength what sort of the value the particular signal is holding, if you wanted to decide now, and then you have to come across all these 3 terms, that is the driven strength, the next one is the capacitive strength, and the third one is the high impedance strength. Okay, so high impedance strength usually is not a strength to be considered, and the strength of a net is derived dynamically from the strength of a net drivers and will get the strength of the strongest driver. So usually how can we decide the strength of a particular signal is only with the help of a strength drivers. From the strength drivers we can, from the net drivers, from the strength of the net drivers, we can easily derive the strength of a particular net. So the word strength 0. So here the word strength 0, it specifies the strongest driver. So here the net strongest driver is giving the value to that particular strength as 0, isn't it? So the word strength 0 is specifies the strongest driver, and the word strength 0, it specifies the strength when the net drivers drive the value 0. So this particular, we are calling the word strength 0, it specifies the strongest driver, first thing is. And the next thing is, the word strength 0, it specifies what? It specifies the strength. The word strength 0, it specifies the strength when the net driver drives the value 0. So it is all based on the driver. Okay, so it's all based on the net driver. If the net driver is driving the strength value as 1, then we are calling it as a strength 1. And if the net driver is driving the strength 0, then we are calling it as a strength 0. So it's totally depends upon the net driver. Okay, the strength of a net driver. When if it is driving the 0, then we are calling it as a strength 0. If it is driving towards a 1, then we are calling it as a strength 1. And then the cap strength for Trireg nets. So the cap strength mainly used only for the Trireg nets. So the table shows the strength. Here we have a table. In this table, it just shows out the strengths of that particular value, particular strength of a particular signal. So here we see the strength level is 7, which is a high. So the strength level is 7 given to the supply drive. And here the keyword that we use is supply 0 and supply 1. So the important thing you have to remember for the exam point of view is, if you want to write and if you want to give, if you are asked to give any strength values regarding to the strength values with respect to the names and as well the keywords. So this is an important table to be remembered. So in the table, we'll come across the strength. Based on the strength, the name of a strength would be given, and as well as the keywords that are suggested to write in a program. So if the strength value is 7, then the supporting keywords would be supply 0 and 1. So the name, as the name indicates here, supply 0 and 1, the name given is supply drive. Okay, and then the strength value 6. So for this 6, the name given is strong drive. Okay, so supply drive is for 7, and the names or as the keywords we use supply 1 and 0, and the 6 is a strength signal. It's a 6. The strength 6 is a strength level. For this strength level, the name indicating is strong drive, and for this strong drive, using a keyword, I can write strong 0 and strong 1. Okay, strength level is 6. 6 is for strong, and strength level is 7. 7 is for supply. Okay, and the keyword is meant for 0 and 1. Whereas here, the strong is meant as strong 0 and strong 1. Coming to the 5. If the strength level is 5, what sort of name that we can give is, if the strength level is 5, then it's nothing but the pull drive. Okay, the particular variable or as a particular net is called as a pull drive. So pull drive is nothing but, again, the keyword that we can use is pull 0 and pull 1. Okay. And then coming to the fourth one. Fourth one is large capacitive. Okay. So if the signal strength, or else if the strength value level is 4, then such particular variable called as the large capacitive. Okay. And in the program, for this particular large capacitive module, the keywords that we use is large. Based on the strength value, we are getting based on the strength value, we are writing we are using the keywords, right? And then coming to the 3. 3 is nothing but the weak drive. So weak drive, we have to use the 2 keywords, that is weak 0 and weak 1. And then for 2, okay, strength signal is 2. If the strength level is 2, then it's a medium capacitive, and this particular keyword that we use is medium. And then goes with the 1 and 0. So for 1 and 0, we use small capacitive is for 1, and high capacitive, high impedance is for 0. So 0 is a high impedance value. Okay. And the keyword that we use is high 0 and high Z0, high Z01 and high Z1. And for small capacitive, as the strength level is 1, then the keyword that we use is small. So this is a small table, but very important table to remember in order to write a particular program based on the module that you are considering and the signal strength, or as the strength levels of that particular module. If any case, if you come across all the signal strengths, then this is these are the keywords that you have to remember when you're writing the program. Okay, so this is very important table to remember. Coming to the default strength. The default strength is a strong drive. So here, the default, just now we have seen the strength levels, right? 7 to 0. So 0 is nothing but the high impedance. 0 is nothing but the high impedance, and here for high impedance we are calling we are making use of the keywords as high Z0 and high Z1, and 7 is nothing but the name given as supply drive. So for this supply drive, we are making use of 2 keywords, that is supply 0 and supply 1. Okay. Then for pull up and pull down gates. So here, for enhancement mode of transition and the depletion mode of transition, for pull up and pull down gates, the default strength is pull drive. Okay. So for pull up and pull down switches, we have already discussed about the switch primitives, right? So for pull up and pull down switches, for such kind of modules, the strength would be based on the pull drive. Okay. For trig rate, the default strength is medium capacitive. So these are for the switches, it is a pull drive, and for the Trireg nets. So for 3 nets, so for Trireg nets, we say the default strength would be medium capacitive. So what is this medium capacitive? Medium capacitive is 2, isn't it? So for Trireg nets, the medium capacitive is a keyword that we can use. So the strength level is 2. This is only, the strength level is 2 only for the Trireg nets. And for supply nets, the default strength will be supply drive. So for the supply nets, we see the signal level strength level will be 7. Okay. And 7 is nothing but the supply. So here we use the 2 keyword, that is meant with the supply 1 and supply 0. Okay. So for pull up and pull down, we use a pull drive strengths, and for the Trireg nets, we use the capacitive medium, that is medium capacitive, whereas the strength level is 2, and for the default strength, okay, for supply nets, we use the strength level 7. It can supply for 0 and as well as for 1. And Trireg nets hold their last strength. So usually Trireg nets, the signal strength or the strength level for this Trireg nets is 7. So usually the Trireg nets, these variables, what they hold the last strength. Okay. In the execution, they hold the last previous strength of a particular signal. And supply nets have supply strengths. Usually for supply nets, we have the supply strengths. For Trireg nets hold the last strength. Trireg nets usually they have the medium capacitive. That means the signal strength would be 2. And for the supply nets, they have the signal level as 7 and they have the supply strengths. Here in the example they have given for AND gate, the signal strength is strong 1 and weak 0. And this is the name of a gate that you are using, and here is a port list. In the port list, we are representing the output and input ports. But here is a strength level. Okay, this is a strength level. Usually, in the previous section, we have discussed the delays, right? When it comes to the delays, usually we will represent the delays like this. So, in the same way, the strengths of a particular signal can also be represented in terms of the strong or weak, or else in terms of the capacitive impedance, or else high impedance, and the low impedance and the medium impedance. So this is how the representation of the signal and the strength of a particular level can be represented, and is the name of a module that you are considering. Okay, and then Trireg. For Trireg, the condition goes with this is small. So compared to the cap strength, for this module, the cap strength is medium, the cap strength is small. Okay, small C1. And assign is a keyword where we have to use a keyword assign. Assign keyword weak 1 and strong 0. So here the weak 1 and strong 0, this is nothing but the discrimination. The discrimination between the signal strength based on the level. Okay, based on the level and the propagation. So here it is weak 1 and strong 0. So as it is a gate that we are using is AND, that means we have to add the two operands A and B, and the output is stored in Q. Q is equals to A and B. The strength of a signal goes with the variables that it is with the variable that the net is having is a strong 1 and weak 0, and assigning is weak 1 and strong 0 as well. And the net declared as Triregs can have capacitive strong. So here, as this Triregs have the signal strength or as a capacitive strength, the strength value for the Triregs is 2. 2 is nothing but the capacitive medium capacitive. So here the nets declared as Trireg, they can have the capacitive storage, and such storage can be assigned one of 3 strengths. So here the capacitive storage, the strength level is 2 for the Trireg nets, and the capacitive holdings can be in the 3 strengths, 3 levels, that is medium, small and large. And then driving such kind of Trireg nets, okay, driving such kind of nets from different sources can lead to contention. Okay, so here what this sentence is saying is driving such nets from different sources. So as we are considering, for example, if you are considering any complex circuit, okay, so for each and every module we have the nets, right? So each and every net from different modules, it can lead to the contention of the strength of a signal. Okay, contention of that particular signal. The strength of a signal, the strength of a net, okay, the strength of a signal or the strength of a variable or a net is derived based on the strength of multiple drivers, and the final strength will get strength where log provides 3 types of strengths. So here the strength of a net, okay, the strength of a net is totally based on the strength of a multiple drivers, isn't it? One driver, it drives the strength of a signal, and that driven strength, it could be either in the supply level, it could be either in the strong 0 level or strong 1 level. It totally depends on the driver of a net. Okay, the net drivers is driving the particular strength, and that strength based on the level he can drive. So here the strength of a net is driven based on the strength of multiple drivers. Okay, multiple drivers. Sometimes one net driver can it drives the particular signal, okay, based on the strength. It could be either supply 0 or 1. Sometimes what happens, multiple drivers will come into the existence. So the multiple drivers based on the signal strength, okay, based on the signal strength 5, 3, 2 or 1. Okay, that means what? Based on the high impedance value. If the source driver, is driving towards a high impedance, then the signal strength would be 0. The strength level goes to 0. So it's totally based on the multiple drivers. And but the final strength will be get the strength Verilog provide the strengths of the types of the strength. So the types of the strengths are nothing but the driving strength, capacitive strength and high impedance. Okay. So based on the 3 values. So here you can see the strength type. So this is a type. This is a type. If a driver is driving with a net driver is driving with a strength type of capacitive strength. So for this capacitive strength, we can say if the driver is going with respect to the capacitive strength, then that particular signal will have the large capacitive, medium capacitive and small capacitive. That means what? Again, if the driver is going with a capacitive strength, there is a segregation, okay? There is a division between the capacitive strength based on the large, medium and small. And if the driver is going with respect to the driving strength, okay? Such driving strength is based on the supply drive, strong drive, pull drive and weak drive. So here, in first type, that is in the driving strength, we see 4 sort of driving levels. Okay, 4 sort of driving level. That is supply drive, that is supply 0 or 1, and the strong drive, that is strong 0 or 1, and the pull drive, that is pull 0 or 1, and the weak drive, that is weak 0 or 1. Okay, so these are nothing but the keywords. When the driver is initiating its driven signals, driven strength based on the capacitive strength. Okay, based on the capacitive strength, then he has to go through this supply strength, supply drive, strong drive, pull drive and as well as a weak drive. And if suppose the net driver is going with respect to the high impedance, okay, for this in such kind of high impedance, we see the strength of a particular signal as usually with respect to the high impedance. So this is a table. It tells us about the name of a particular, the strength type. Based on the strength type, the name given or else the keywords can be assigned. Okay. So we have 3 types of strength types. They are with respect to driving strength, capacitive strength and high impedance. And the keywords used in the Verilog strength. So here in the Verilog strength, these are the keywords used. So we know the strength levels are from 0 to 7. So 0 is nothing but the high impedance. So for high impedance, we represent the keywords as high Z0 and high Z1. And then goes with the signal strength level 1. For the strength level 1, we see the small capacitive. Okay, capacitive strength. So the capacitive strength, the keyword used is small. And for the signal strength 2, strength level 2, for this 2 it is a medium level. And then the keyword used is medium. And if it is 3, weak drive, and the keyword goes with respect to the weak. Why? Because in the capacitive, in the driving strength, in the previous slide we have discussed about the driving strength, right? So for this driving strength, we have seen the different names can be given. Being a driver, the strength of a driver, net driver, for such driving strength, the names can be given in terms of strong drive, supply drive, pull drive and weak drive, isn't it? So for each and every drive, it goes with 0 and 1. So it goes with 0 and 1, 0 and 1. So these are nothing but as it is a weak drive, if the strength level is 4, this call is a weak drive and we have weak 0 and weak 1. And if the strength level is 4, so for this 4 we have large capacitance. Okay, so large capacitance is nothing but the keyword that we can use, or as a variable that particular net is holding is of large. And for the 5th strength level, so for the 5th strength level, we are calling it as a pull drive. So for this pull drive, we have usually pull 0 and pull 1. So pull drive is for 5. The signal strength level is 5. And for weak drive, is strength level is 3. Okay. And then goes with the strong drive. Strong drive is usually strong 0 and strong 1. So the 6 is strong drive and here we can say this is a strong drive 6, and then supply drive is holding a strength level, has the highest strength level as 7, the supply drive. So this supply drive is 7. So in the driving strength, we see the 3, 5, 7 and 6. 3, 5 and 7 and 6. These 4 are arising with respect to the driving strength. Okay. See, the default strength is a strong drive. So you have to remember all these 7 points to be remembered, which are important. We say the default strength. The default strength is nothing but the strong drive. So again in the strong drive, we say strong 0 and strong 1. And then the default strength for pull-ups. For pull-up and pull-down gate is pull drive. So with respect to the strong drive, we say strong 0 and strong 1. And that is a default strength. Strong 0 and strong 1 is a default strength. And for pull drive strength, pull drive is nothing but the pull-up and pull-down. So here you see again 1 and 0. And then the default strength for Trireg is medium capacitive. So medium capacitive is 2, right? So for Trireg nets, the strength level is a medium capacitive strength level and it is 2. And the default strength for supply nets is supply driver. Okay. So for supply driver, we say I think it is 5. And then a net cannot be driven with a high impedance strength. So if you come across the high impedance strength, it is Z. So high impedance strength, then in such cases, we see that the net cannot be driven. That means what the variables a particular net is holding cannot give the variables to the input. Okay. So the net cannot be driven when the high impedance strength. So in terms of high impedance strength, the net cannot be driven. And high Z1, high Z0. So these are nothing but the strength combinations. Okay. High Z1 and high Z0 and high Z0 and high Z1 strength combinations are not allowed. So here you can see either 1 or 0 and 0 or 1. But both the high impedance capacitive drivens are not allowed together at once. Okay. And then if a net is driven with low or high simultaneously, the result will be unknown. So for example, if a net is having values 0 and 1, okay, with low and high, and if these two are taking part at a time simultaneously, okay, when these two driven strength levels are taking part at a time simultaneously, then in such cases, we see the result would be the unknown result. Okay. So here, these 7 points talks about the strength of a particular signal based on the levels, strength levels. Okay. Sometimes the strength levels will be pull drive, strong drive, supply drive, capacitive drive, and as well high impedance, and also the result will be X. Result will be X only when the two nets, when they are driven 0 and 1 simultaneously. Okay. So these are the 7 points to be remembered. And coming to the syntax. So here syntax goes like this. Strength 0, strength 1 and strength 0 and capacitive strength. So here in the syntax you can write in either terms. Either first with 0 or with 1, and with 1 and as well as with 0. And last is capacitive strength. So the capacitive strength it holds the levels of the 3 particular levels, that is high, large, medium and as well as small. So strength 1 is nothing but the level of a particular, see here, when net drives the value as 1, the strength is specified by the strength 1. So as I said it totally depends upon the net drivers. Okay, if a net driver is driving with the strength 0, then with the 0 is nothing but the strength of a particular signal, then it's specified with the strength 0. And if a net driver is going forward with the strength value 1, then the strength of a particular value or strength can be given as 1. And cap strength is nothing but for Trireg nets. Okay, for capacitive medium, for Trireg nets, the capacitive strength can be applicable. Okay, only for the Trireg nets this capacitive strength can be applicable, and this capacitive can in terms of three levels, that is large, medium and small. So these are nothing but the capacitive strength, and they can be used only for the Trireg nets. So here example they have given. In the particular example we see OR gate. Okay, OR gate, the name of a gate that you are using is OR gate. And coming to the strength level. So strength level is strong 0 and weak 1. Okay, strong 0 and weak 1, these are nothing but the this sort of things, the combination of strong and 0. We can see these are nothing but the driving strengths. Okay, the driving strengths has four sort of driving elements. They are supply, strong, pull and weak. So driving strength. So here in this particular example, or is the gate that we are using, and the strength level is driving strength. We see here the driving strength, strong 0 and weak 1. And here we have the name of a particular module that we are considering, name, and the port list, output ports and as well as with the input ports. Assign is a keyword used to represent when it comes to the driving strengths. Assign weak 0, strong 1, which is equals to A and B. And then for Trireg nets. So for this Trireg nets, as I said you, the cap strength of a particular Trireg net that we have considered here is large. Okay, large Trireg 1. So here in the three statements, first statements we are representing the syntax with respect to the strong level strength. Okay, or the name of the module that you are considering, level strength goes with the name of module and with the port list. And the second statement is talking about the basic keyword assign. Assign again the strength levels. Okay, level strength followed with the output, the representations of or is the Boolean expressions of that particular input that you have considered. And finally, the Trireg nets. The Trireg nets is nothing but the representation of the level. Okay, the level of what sort of the level it's holding. So here we see this particular thing is holding as the large. The large signal strength can be given for this Trireg nets with respect to TR1, the name of a particular net. Here, the Verilog strength example. Here we see the strength example when below OR and AND operations drives the same output, the final strength of a output with the strength of the strongest driver. So here he's asking us to consider the two examples, and OR. So in the both and OR, we see the supply and the strong. So based on the driver, based on the strongest driver it's holding, we see for OR gate two sort of things we see. That means what? The driving strength for the supply with respect to the supply is 1, and with respect to the pull drive is 0. Okay, supply drive is 1 and pull drive is 0. This is for the OR gate. When it comes to the AND gate, the strong drive is 1 and the weak supply drive is 0. Okay, we are seeing the different driving constraints. So different driving constraints with respect to AND OR gates. Okay, but here the port list is one and the same. Only the representations of the signal strengths, the strength levels. See here we see the supply drive and we see the weak drive. Okay, this pull drive holds a value of 3, I guess, and supply drive holds a value of 6. Whereas a strong drive holds a value 7 and supply drive holds a value of 6. Okay, and here in the example, input driven in the table given, input driven, output strength and the explanation. So here input driven, in this input driven we see 0 and 1 is equals to 0. When 0 is equals to 0 and 1 is equals to, so here we see output is pull 0. Okay, so the pull 0 is strength 5, weak 0 is strength 3. So here we should see the levels 3 and 5. Level 3 and level 5. So level 5 is nothing but the, level 3 is nothing but the pull, level 5 is pull, and level 3 is nothing but the supply. Okay, and coming to the second one, out is equals to X. So output strength is X when the input driven is 1 is equals to 0 and 1. So if it is 0, 0, we see if it is 0, 0, the output strength is 0. If it is 0, 1, the output strength is unknown value. And if it is 1, 0, output strength is unknown value. And if it is 1, 1, the output strength is 1. As I said you, when both the inputs, that is 0, 1 and 1, 0, if they are simulating concurrently, if they are simulating simultaneously, obviously the output goes to the unknown values. Okay, the output goes to the unknown values. So this is what we have observed in this particular example. In this particular example, we have observed that when the two inputs 0 and 1 and 0, if they are simulating concurrently, simultaneously they are simulating, then obviously the result output goes with the unknown value X and X. Okay, if both are 0, then we see the output goes as 0. If both are 1, we see the output goes as 1. So for this signal, the strength level is 7. So 7 is nothing but the, it's a strong, isn't it? The 7 is nothing but the strong strength level, strong one, and the strength is 6. And for this, for 0, 0, and for this 0, 0, the strength levels are goes with 5 and 3. Okay, 5 and 3. So this is a simple example and explanation given with respect to the Verilog strength, with respect to the strength levels of a particular module. So here two sort of modules I have considered, OR and gate, and this is how the representation goes with respect to the strength levels of that particular modules. And this is, we know that in the AND and OR gate, we know truth table 0, 0, 0, 1, 1, 0 and 1, 1. Whereas in the Trireg nets operations, we see when it is goes 0 and 1 and goes simultaneously takes place, we see these are the unknown values. And only thing you have to ponder on, when both the inputs are going with respect to AND gates, it is 0, and if it is both the inputs are going with respect to 1 and 1, then output goes to 1. When it is 1, we see the signal level strength of that particular signal is high. Okay, 7. And here it goes with the 6 or 3. So this example, module strength, module is a keyword that we are using, and strength is based on the strength levels that we need to consider. Input port, port list, output port, and as well as the input port. So here we see the assign is a keyword, supply 1 and pull 0. So here we see the two sort of strength levels, driving strengths. These two comes under the driving sense, and in the driving sense we see supply strength, supply driven, and the pull drive and supply drive. So here we see, usually we'll take the supply drive as 0 and 1, and the pull drive as 0 and 1. So here, this particular example, I'm considering supply 1. Okay, I'm considering supply 1, and as well I'm considering the pull 0. Okay, pull 0 and supply 1, where my output is, this is XOR, right? So I2 XOR I1. I1 XOR I2. Then assign strong. So here I'm considering two things. Two bitwise operators I'm considering, OR and AND. So assign strong 1 and supply 0. So here one more drive I'm considering, that is the strong drive. So it is 0 and 1. So for this AND gate, so for this AND, the strength levels goes with the strong 1 and as well as supply 0. Strong 1 and as well as supply 0. So this is for AND and this is for XOR. Okay. So finally OR and XOR. Next, OR supply 1 and pull 0, out 0 and 1, and this is AND. Supply 1 and strong 1 and supply 0 out. Then finally end module. So this particular example says that we can write the particular program based on the bitwise operators, based on the logical operators. Okay, And main thing you have to concentrate here in the strength and the Trireg nets is in the syntax. Immediately after the keyword module, you have to represent the name of a gate and or gate, and immediately followed with the strength of a particular driving element. Okay, so here the driving element is I've considered supply and as well as the pull. So sometimes we can write strong 0 and weak 1. So this is sort of simulation, or this is sort of the this is about the signal level. Okay, signal level that I have considered. So this is how I can write about the Trireg nets with respect to the strength of a particular signal, and as well the syntax goes with respect to the signal level of a signal strength. This is about the strength, right? So some case in the previous classes we have discussed about the delays as well. So in the delays, usually we used to write like this. How module, okay, and gate, and here the delay, and goes with the port list, right? And then initial, begin, again delay A and B, delay of 10 nanoseconds, which is equals to A and B, delay of 20 nanoseconds C and D, and finally end here end module. So this is what we used to write in terms of delays. Okay, in terms of delays. But when it comes to the strength of a particular signal, okay, the level of a strength. So in case of level of strength, these are the things that we have to remember and write when it comes to the strength of a signal. This is an important example for the exam point of view. You just learn all this. This example is well and fine. And this is a syntax. This three kinds of strength we have: strength 0, 1, and the cap strength. Cap strength goes with the for Trireg nets. Only cap strength is applicable. And the cap strength it has 3 levels. The level of a signal can be medium, large, and small. And then strength 0 and strength 1 is totally depends based on the drivers, the net drivers. Based on the net drivers. If the net drivers is driving its value with 0, then we call the strength of that particular signal as strength 0. And if the net driver is driving with the strength 1, value 1, and then we call that particular signal with the strength value of the particular signal strength is 1. And then capacitive strength for Trireg nets, the capacitive strength is considered to be applicable, and under the capacitive strength we have only 3 sort of strengths: 0, medium, large, and small. And these are the 7 important points to be remember. Here we have the pull drive, strong drive based on the strong signal, that is 0 or 1, and pull drive based on the pull up and pull down gates. And the keywords that used under this pull drive is pull 0 and pull 1, and the medium capacitive Trireg nets. And this the signal value or as level strength is 2. And then for the supply nets, the level strength goes with the 5, and high impedance state. So high impedance states are nothing but the high impedance states, they cannot drive the net. Here for high impedance states, the nets cannot move, or else the nets cannot give out the values, whether it with respect to the input and also with respect to the output. And the important thing to remember is the result. If you are getting any unknown value, it means that the input 0 and 1 and 1 and 0 simultaneously, if these 2 values, if they are not driven simultaneously, okay, the 2 values are driven simultaneously, if for suppose, and in such cases we see the output goes with the unknown value. So likewise in the AND gate, in the previous slides we have discussed, for the AND gates 0, 0, 0, 1, 1, 0 and 1, 1. We see 1, 0 and 0, 1. The net is driven with 1, 0 and 0, 1. In such cases, we have seen the output result as the unknown values. Okay. Whereas for 0 and 0, we see the output as 0, and 0 and 1, we see the output as 1 with respect to the signals level strength, signal strength or signal levels. Sometimes it is 8 or sometimes it is 5. In rare cases, we find the level of such particular signals would be the capacitive medium. It is 5 or 4. Okay. So this is important. And the keyword signal strength. So here for high impedance, the representations of the keywords goes with high Z or Z1. And whereas here also in this particular high impedances, we see these two cannot run simultaneously. Okay, the simulation of this particular two keywords cannot run simultaneously, where you see the output goes with the high impedance value Z. And something else, we have the types of, there are 3 types of strength: driven strength, capacitive strength, and high impedance strength. So driven strength goes with the supply strong, weak, and pull. And the capacitive lens goes with the large capacitive, medium, and the small capacitive. And the impedance goes with the high impedance. Sometimes it goes with high Z0 and high Z1. Sometimes high Z1 and high Z0. So this is all about the Trireg nets and the signal capacitance with respect to the Trireg nets, signal contents with respect to the Trireg nets. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.